June 4th, 1942. The Pacific Ocean stretched endlessly beneath Lieutenant Commander John Thach as his formation of six Grumman F4F Wildcats climbed desperately toward 20,000 feet. Through his cockpit canopy, he could see them coming. 18 Mitsubishi, a 6M0 fighters, descending from the sun like silver arrows of death, their pilots among the most experienced naval aviators in the world. The mathematics of aerial combat were brutally simple that morning. The Zeros were faster, more maneuverable, and flown by veterans who had been perfecting their craft since the invasion of China in 1937. Thach's Wildcats were outmatched in every performance category except one, and that single advantage would have to be enough to survive the next 10 minutes. What Thach couldn't know as those 18 Zeros bore down on his formation was that he was witnessing the final months of Japanese air superiority in the Pacific. Within 2 years, the aircraft that had terrorized Allied forces from Pearl Harbor to the Philippines would become little more than targets for a new American fighter that would rewrite the rules of naval aviation. The Grumman F6F Hellcat was still 18 months away from its combat debut, but when it arrived, it would systematically dismantle the myth of zero invincibility and hand the United States complete control of Pacific skies. This is the story of how American industrial might, tactical innovation, and sheer determination transformed a desperate defensive struggle into the most decisive air superiority campaign in military history. It's the story of how one aircraft broke the back of Japanese naval aviation and cleared the skies for the island hopping campaign that would carry American forces to Tokyo Bay. The collapse of Japanese air dominance didn't happen overnight. It was methodically engineered in the design offices of Grumman Aircraft on Long Island, refined in the test flights over Connecticut, and perfected in the crucible of Pacific combat. Every rivet, every control surface, every ammunition round was calculated to counter specific Japanese advantages while exploiting their hidden weaknesses. The Hellcat represented more than superior engineering. It embodied a complete reimagining of fighter aircraft philosophy, trading the elegance of the Zero for the brutal efficiency of American mass production. But to understand how the Hellcat shattered Japanese air power, we must first understand why that air power had seemed unbreakable. On December 7th, 1941, as the first wave of Japanese aircraft approached Pearl Harbor, they represented the culmination of 2 decades of aerial warfare evolution. The pilots flying those Zeros had trained for years in the demanding art of carrier aviation. Their aircraft, though lightly built, possessed a climb rate and turning ability that made them nearly untouchable in the hands of skilled pilots. More importantly, they carried with them the confidence of an undefeated force that had swept Allied air power from the skies across half the Pacific. The A6M0 had achieved something unprecedented in aviation history. It had combined long range with exceptional maneuverability, allowing Japanese carriers to strike targets hundreds of miles away while maintaining air superiority over the battlefield. The secret lay in its radical weight savings. By eliminating armor protection, self-sealing fuel tanks, and heavy armament, Mitsubishi had created an aircraft that could outmaneuver anything the Allies could field. In the hands of experienced pilots, this combination proved devastating. Allied fighters found themselves unable to escape Zero attacks through superior speed or outmaneuver them in turning combat. The psychological impact of Japanese air superiority extended far beyond tactical victories. Allied pilots, accustomed to technological advantages, suddenly found themselves flying obsolete aircraft against superior enemies. The Buffalo fighters defending Singapore were massacred. The P-40S over Burma were overwhelmed. Even the vaunted Spitfires of the Royal Air Force struggled against Zero formations over Darwin, Australia. By mid 1942, Japanese naval aviation had achieved what no air force in history had accomplished: complete air superiority across an ocean spanning nearly half the globe. Yet, even at the height of their success, the seeds of Japanese defeat were already being planted. The Zero's advantages came at a terrible hidden cost. Its light construction, while enabling superior maneuverability, made it incredibly vulnerable to battle damage. A single burst from heavy machine guns could destroy the unprotected fuel tanks or kill the pilot who sat behind minimal armor. More critically, Japan's pilot training system, while producing exceptional aviators, could not replace them quickly enough to sustain heavy losses. The Americans, meanwhile, were learning lessons that would prove crucial to developing the Zero's nemesis. Every encounter, every combat report, every gun camera film was analyzed for weaknesses in Japanese tactics and aircraft design. At the Navy's Fighter Tactics School in San Diego, instructors dissected Zero performance characteristics, developing new combat techniques specifically designed to counter Japanese advantages. The most famous of these innovations was the Thatch Weave, a defensive maneuver that allowed slower American fighters to survive encounters with superior Japanese aircraft. But survival wasn't enough. The Pacific War demanded more than defensive tactics. It required an aircraft that could not only match the Zero, but decisively defeat it in every category of aerial combat. This requirement reached the Grumman Aircraft Corporation in late 1941 as the full extent of Japanese air superiority became apparent. The company's previous fighter, the F4F Wildcat, had performed admirably in the hands of skilled pilots like Thatch, but it was clearly outmatched by the Zero in most performance categories. Grumman's response would revolutionize fighter aircraft design. Rather than attempting to match the Zero's lightweight philosophy, the company chose a radically different approach. The F6F Hellcat would be bigger, heavier, and more powerful than any carrier fighter ever built. Where the Zero sacrificed protection for performance, the Hellcat would achieve superior performance while maintaining unprecedented survivability. The aircraft would embody American industrial philosophy, brute force engineering backed by unlimited resources and manufacturing capacity. The design philosophy that created the Hellcat represented a fundamental shift in American thinking about air combat. Previous fighters had emphasized speed and maneuverability as primary virtues. The Hellcat would demonstrate that firepower, protection, and production capability could be even more decisive in sustained combat. Every aspect of the aircraft was engineered not just for performance, but for manufacturability, maintainability, and pilot survival. This wasn't just building a better fighter. This was building a weapon system designed to win a war of attrition. Roy Grumman himself understood what his company was attempting. In a meeting with Navy officials in March 1942, He outlined the challenge they faced. The Japanese had a 5 year head start on carrier aviation and pilots with thousands of hours of combat experience. American pilots were arriving in the Pacific with minimal training and inferior equipment. The solution wasn't just a better airplane, but a complete system that could quickly transform novice pilots into effective combat aviators while giving them every possible advantage over their more experienced enemies. The technical specifications that emerged from these discussions would have seemed impossible just months earlier. The new fighter would need to carry heavy armament while maintaining carrier compatibility. It would require armor protection and self sealing fuel tanks without sacrificing performance. Most challenging of all, it would need to be manufactured in quantities that could replace losses while building up overwhelming numerical superiority. The Hellcat program represented the marriage of American industrial capacity with hard learned lessons from Pacific combat. The engine selection alone demonstrated the scale of American ambition, where the Zero relied on a 1,130 horsepower Nakajima Sakai radial engine. The Hellcat would be powered by the Pratt and Whitney R2800 double wasp, an 18-cylinder radial producing 2,000 horsepower. This massive engine, the same power plant that would drive the P-47 Thunderbolt and other American warplanes, represented American industrial might at its peak. The engine alone weighed more than many complete Japanese fighters, yet it would provide the power necessary to carry heavy armament, armor protection, and advanced avionics while still achieving superior performance. The armament package reflected lessons learned from early Pacific combat, where Japanese fighters typically carried 220mm cannon and two machine guns. The Hellcat would mount 6.50 caliber Browning machine guns with 400 rounds per gun. This represented a combined rate of fire exceeding 6,000 rounds per minute, enough concentrated firepower to destroy any Japanese aircraft in a brief burst. The ammunition itself was a marvel of American manufacturing, with each cartridge precision manufactured to tolerances, measured in thousandths of an inch, and loaded with advanced propellants and projectiles designed specifically for aircraft destruction. But raw firepower meant nothing without the ability to bring those guns to bear on target. The Hellcat's design prioritized pilot visibility and aircraft handling characteristics that would allow average American pilots to engage and defeat veteran Japanese aviators. The cockpit was positioned high on the fuselage, providing exceptional forward and downward visibility crucial for carrier operations and air-to-air combat. The controls were designed for ease of operation, allowing pilots to focus on tactics rather than fighting their own aircraft. Protection was equally revolutionary. The Hellcat incorporated lessons learned from analyzing damaged Wildcats and studying Japanese ammunition effectiveness. Armor plates protected the pilot from front, rear, and sides. The engine was shielded by heavy steel plates that could absorb 20mm cannon strikes. Most importantly, all fuel tanks were self-sealing, preventing the catastrophic fires that had destroyed so many Allied aircraft in early Pacific battles. This protection came at the cost of weight and complexity, but American pilots would discover that survivability was worth every additional pound. The manufacturing challenge was immense. Grumman's Bethpage facility would need to produce not just prototypes, but thousands of combat aircraft while the war raged across the Pacific. The company invested heavily in new production techniques, automated machinery, and worker training programs. By 1943, the Bethpage plant was completing one Hellcat every hour, a production rate that would have been impossible without American industrial infrastructure and manufacturing expertise. The first prototype, PSX F6F1, rolled out of the Bethpage hangar on June 26, 1942, exactly 6 months after Pearl Harbor. Test pilot Robert Hall approached the massive fighter with a mixture of excitement and apprehension. At 12,186 pounds empty weight, the Hellcat dwarfed every carrier fighter that had come before it. The aircraft looked like what it was, a flying fortress designed to absorb punishment while delivering devastating firepower. Hall's first flight report captured the revolutionary nature of what Grumman had created. The power was unlike anything he had experienced in carrier aviation, smooth and seemingly unlimited even at high altitude. But power alone wouldn't win the Pacific War. The Hellcat needed to prove itself capable of carrier operations while maintaining the performance advantages necessary to defeat the Zero. The initial test flights revealed both promise and problems. The aircraft's climb rate exceeded all expectations, reaching 20,000 feet in under 7 minutes. Its dive performance was exceptional, maintaining control effectiveness at speeds approaching 500 miles per hour. Most importantly, the Hellcat demonstrated rock-solid stability in all flight regimes, a crucial characteristic for pilots who would be fighting for their lives while learning to master their aircraft. The carrier compatibility trials conducted aboard USS Yorktown in February 1943 would determine whether the Hellcat could transition from promising prototype to combat weapon. The sheer size of the aircraft created immediate concerns among Navy pilots accustomed to smaller fighters. The Hellcat's wingspan stretched 42 feet, nearly 6 feet wider than the Wildcat it was designed to replace. Landing on a carrier deck had always demanded precision and nerve. Attempting it in an aircraft the size of a medium bomber seemed almost suicidal. Lieutenant Commander Butch O'Hare, already a Medal of Honor recipient for his actions against Japanese bombers, volunteered for the first carrier landing trials. His assessment would carry enormous weight, with Navy leadership still skeptical about deploying such a large aircraft from carriers. O'Hare's approach to Yorktown's flight deck demonstrated the Hellcat's remarkable handling characteristics. Despite its size and weight, the aircraft responded predictably to control inputs. The massive engine provided plenty of power for wave-offs and go-arounds. Most importantly, the Hellcat's low landing speed and excellent visibility made carrier operations safer than anyone had dared hope. The success of carrier trials accelerated production plans, but Grumman faced a challenge that went beyond manufacturing capacity. The Hellcat incorporated advanced technologies and systems that required new maintenance procedures and pilot training techniques. Every squadron transitioning to the new fighter would need extensive retraining on everything from engine management to weapon systems. The complexity was unprecedented in carrier aviation, but American training infrastructure proved equal to the challenge. Training squadrons established at naval air stations across the United States began preparing pilots for a new kind of aerial warfare. The Hellcat demanded different tactics than any previous American fighter. Its combination of speed, firepower, and protection allowed aggressive tactics that would have been suicidal in earlier aircraft. Pilots learned to use the Hellcat's superior power to weight ratio to maintain energy advantages over Japanese fighters. They practiced high speed diving attacks capit that's exceptionalized on the aircraft's structural strength while avoiding prolonged turning engagements where Zero maneuverability remained superior. The weapons training alone represented a revolution tactics. 6 in-fighter 50 caliber machine guns delivered firepower that could destroy any Japanese aircraft with a brief burst, but only if pilots could bring those guns to bear accurately. Gunnery training intensors taught pilots to make a fight as instruct every shot count. The Hellcat carried enough ammunition for extended combat, but conservation remained crucial in the vast distances of Pacific operations where returning to base for rearming might be impossible. By August 1943, the first operational Hellcat squadron, VF5 aboard USS Yorktown, was declared ready for combat. The 27 pilots of Fighting Squadron 5 represented the culmination of 18 months of intensive development, testing, and training. They were about to carry American hopes into battle against the most experienced naval aviators in the world. Squadron Commander Lieutenant Commander Charles Crommelin understood the weight of expectations. The Hellcat had been designed specifically to defeat the Zero, but no amount of engineering could guarantee success against pilots who had been perfecting their craft for years. The psychological preparation was as important as the technical training. American pilots had spent nearly 2 years hearing about Zero superiority and Japanese pilot expertise. Breaking through that mental barrier required confidence in their equipment and faith in their training. The Hellcat provided both. Pilots who flew the new fighter discovered aircraft that responded instantly to their commands while providing protection they had never experienced. The massive engine delivered power on demand, allowing escape from dangerous situations that would have proven fatal in earlier fighters. Intelligence reports from the Pacific provided crucial insights into Japanese tactics and weaknesses that Hellcat pilots could exploit. Combat analysis revealed that Zero pilots relied heavily on their aircraft's superior maneuverability to win turning engagements. They were less experienced in high-speed combat, where the Hellcat's advantages would be most pronounced. Most significantly, Japanese pilot training had focused on individual excellence rather than formation tactics, creating opportunities for coordinated American attacks that could overwhelm even superior pilots. The strategic situation in August 1943 could not have been more favorable for the Hellcat's combat debut. Japanese naval aviation, while still formidable, was beginning to show signs of strain after nearly 2 years of continuous combat. Veteran pilots who had dominated the early war were being lost faster than they could be replaced. New Japanese pilots arriving in combat zones lacked the extensive training that had made their predecessors so effective. The window was opening for American numerical and technological advantages to begin tipping the balance of aerial warfare. Admiral William Halsey, commanding South Pacific forces, understood that the next major engagement would likely determine the future of carrier aviation in the Pacific. If the Hellcat could prove itself Against veteran Japanese pilots, American forces would possess the air superiority necessary to begin the long advance toward Japan. If the new fighter failed to live up to expectations, the Pacific War might drag on for years with uncertain outcomes. The stakes could not have been higher as VF-5 prepared for their first combat mission. The opportunity came sooner than expected. On August 31st, 1943, intelligence reports indicated a major Japanese carrier force moving toward the Solomon Islands. The enemy formation included veteran squadrons flying from carriers that had participated in attacks on Pearl Harbor and the Coral Sea. These of the Zero fighter. For the most advanced versions were the elite units of Japanese naval aviation flying the Hellcat. There could be no more demanding test of its capabilities. As dawn broke over the Pacific on September 1st, 1943, Lieutenant Commander Crommelin led 12 Hellcats off Yorktown's flight deck into history. The pilots had trained for this moment for months, studying intelligence reports, practicing formation tactics, and familiarizing themselves with every aspect of their revolutionary aircraft. Below them, the vast Pacific stretched endlessly toward a confrontation that would determine whether American industrial might could overcome Japanese tactical expertise and combat experience. The mathematics of the engagement seemed almost impossible. 12 American pilots, most with fewer than 50 hours of combat time, were about to face veteran Japanese aviators flying aircraft that had dominated Pacific skies for nearly 2 years. The Hellcat represented American hopes for technological superiority, but technology alone had never won wars. Victory would require courage, skill, and perhaps most importantly, the ability to exploit the revolutionary capabilities that Grumman had built into their massive fighter. What happened in the skies above the Solomon Islands over the next 30 minutes would reshape the Pacific War and establish American air superiority that would never again be seriously challenged. The Hellcat was about to prove that superior engineering, backed by American industrial capacity and pilot determination, could indeed break the myth of Japanese invincibility and clear the skies for the final advance on Japan. The radar operator aboard the Japanese carrier, Zuikaku, first detected the incoming American formation at 0847 hours. 12 contacts approaching from the southeast at Angels 20 at an estimated speed of 320 knots. In the carrier's Combat Information Center, Commander Takeo Shibata studied the plotting board with growing concern. The Americans were flying higher and faster than any previous Wildcat formation he had encountered. These weren't the lumbering defensive fighters that Japanese pilots had grown accustomed to destroying with impunity. Shibata ordered immediate launch of 18 A6M 50 fighters from the Combat Air Patrol. The pilots scrambling to their aircraft represented the cream of Japanese naval aviation. Flight Petty Officer First Class Hiroshi Nishizawa, already credited with 36 aerial victories, led the formation. His wingman, Petty Officer Second Class Saburo Sakai, had been flying Zeros since the China campaign and possessed over 4,000 hours of combat experience. These were the men who had swept Allied air power from Pacific skies, pilots whose skill and experience had become legendary throughout the Imperial Navy. As the opposing formations climbed toward their rendezvous with history, the technological revolution about to unfold remained invisible to both sides. The Hellcats, ascending through 25,000 feet, carried within their airframes the concentrated might of American industrial engineering. Every rivet had been designed to counter specific Japanese advantages. Every system had been tested and refined through months of analysis of captured Zero aircraft and combat reports from surviving Wildcat pilots. The first visual contact came at 0903 hours. Lieutenant Junior Grade Alex Vracu, flying wing position in the lead division, spotted the Japanese formation climbing steeply from the northwest. 18 silver aircraft in perfect three-plane sections, their pilots maneuvering with the fluid precision that had terrorized Allied forces for 20 months. Through his radio headset, Vrasiu heard Commander Cromwelin's calm voice, directing the engagement. Tally ho, 18 Zeeks at 2 o'clock high. Maintain formation integrity. Remember your training. What the Japanese pilots saw climbing toward them defied their understanding of American fighter capabilities. The Hellcats appeared massive compared to the graceful Wildcats they had grown accustomed to fighting. More disturbing still was their rate of climb. American fighters weren't supposed to outclimb Zeros at altitude, yet these unknown aircraft were matching their ascent rate while maintaining formation discipline that spoke of extensive training and confidence. Nishizawa initiated the attack with textbook precision, rolling his formation into a steep dive designed to build speed while maintaining the energy advantage that had proven decisive in countless previous engagements. His Zero accelerated past 400 miles per hour as he positioned for a high-side run on the lead American division. The maneuver had worked perfectly against Wildcats, whose pilots were forced to break formation and engage in individual turning combat, where Japanese experience and aircraft agility proved overwhelming. The Hellcat pilot's response shattered 2 years of Japanese tactical assumptions. Instead of breaking formation defensively, Cromwell led his division into a shallow climb that maintained their cohesion while building energy. The massive Pratt and Whitney engines responded instantly to throttle commands, delivering power that allowed the heavy American fighters to accelerate even while climbing. For the first time in Pacific combat, Japanese pilots found themselves facing American fighters that refused to be forced into disadvantageous engagements. Nishizawa's first firing pass missed completely as his target aircraft pulled into a climbing turn that should have been impossible for any carrier fighter. The Hellcat's pilot, Lieutenant Junior Grade Hamilton McWhorter, maintained his position in formation while executing a maneuver that would have caused any previous American fighter to stall and fall into an unrecoverable spin. The Zero pilot pulled up sharply, expecting to reverse his advantage, only to discover that the American formation had gained altitude while his own energy bled away in the climbing turn. The engagement that followed rewrote the rules of Pacific air combat. The Hellcats used their superior power and structural strength to maintain energy advantages while forcing the Japanese into increasingly desperate maneuvers. When Zero pilots attempted their traditional diving attacks, the American fighters dove with them, matching their speed while maintaining formation's integrity. When the Japanese tried to escape through superior maneuverability, the Hellcats' overwhelming firepower compensated for any disadvantage in turning radius. The first Zero fell to Lieutenant Commander Cromwelin's guns at 0907 hours. The Japanese pilot, attempting a traditional climbing turn to escape after an unsuccessful firing pass, found his aircraft hanging helplessly as its speed bled away. Cromelin's Hellcat, powered by its massive radial engine, continued climbing at full power while bringing its 650 caliber machine guns to bear. The concentrated firepower that erupted from the American fighter exceeded anything Japanese pilots had experienced. Where previous American fighters might score hits with one or two machine guns, the Hellcat delivered a devastating stream of heavy projectiles that tore the lightly built Zero apart in less than 2 seconds. Petty Officer Sakai, witnessing his formation leader's destruction, attempted to rally the remaining Zeros for a coordinated attack on the American formation. His radio calls revealed the shock and confusion spreading through the Japanese ranks as their tactical advantages evaporated. The Americans weren't fighting like any enemy pilots they had encountered. These pilots maintained discipline under fire, used their aircraft's superior performance to dictate engagement terms, and delivered firepower that made prolonged combat suicidal for Japanese fighters. The psychological impact on Japanese pilots proved as devastating as the technological superiority of their opponents. For 20 months, Zero pilots had approached combat with absolute confidence in their equipment and training. They had grown accustomed to American fighters that could be forced into turning engagements where Japanese advantages proved decisive. The Hellcats shattered that confidence by demonstrating that American industrial might could indeed produce fighters superior to anything in the Japanese arsenal. Lieutenant Vratsu's first kill came during a high-speed diving in a previous American fighter. His target impossible to escape through attempting a Zero attack that would have been a vertical climb, found itself overtaken aircraft, bringing that and should have been left behind by superior Japanese performance. The Hellcat's structural strength allowed Varasu to maintain pursuit through maneuvers that would have torn apart earlier American fighters. When his guns finally spoke, the result was catastrophic for the Japanese aircraft. The ammunition itself represented a revolution in aircraft armament. Each 50 caliber cartridge contained advanced propellants and projectiles designed specifically for aircraft destruction. The armor-piercing incendiary rounds could penetrate the Zero's light construction while igniting its unprotected fuel tanks. The combined effect of 6 machine guns firing in unison created a zone of destruction that no aircraft could survive. Japanese pilots, who had grown accustomed to absorbing multiple hits from lighter American weapons, discovered that even glancing strikes from Hellcat armament could prove fatal. By 0915 hours, the engagement had become a massacre. 8 Zeros had been destroyed without the loss of a single Hellcat, a kill ratio that would have seemed impossible just months earlier. The remaining Japanese pilots, many of them wounded and flying damaged aircraft, attempted to disengage from combat that had become hopeless. Their radios crackled with urgent calls for assistance as the myth of Zero invincibility died in the skies above the Solomon Islands. The Hellcat pilots pursued with relentless efficiency, using their superior speed and firepower to prevent Japanese escape. Lieutenant McWhorter destroyed 2 Zeros in quick succession, his aircraft's massive engine providing the power necessary to maintain pursuit while delivering accurate fire. The structural strength that had seemed like unnecessary weight in peacetime testing proved crucial in high-speed combat maneuvers that would have broken apart lighter fighters. Saburo Sakai, one of Japan's most experienced pilots, barely escaped the engagement with his life. His Zero, riddled with 50 caliber holes and trailing smoke from a damaged engine, limped back toward Zuikaku with news that would shake the Japanese high command. The Americans had produced a fighter that not only matched the Zero, but exceeded it in every meaningful category of performance. More ominously, the pilots flying these new aircraft demonstrated training and tactical sophistication that spoke of systematic preparation for this exact confrontation. The final tally from the September 1st engagement told a story that Japanese intelligence initially refused to believe. 12 American fighters had destroyed 11 Zeros while suffering no losses of their own. The kill ratio represented a complete reversal of previous Pacific air combat statistics. More significantly, the engagement demonstrated that American pilots, given superior equipment and adequate training, could indeed defeat the most experienced aviators in the world. Commander Crommelin's after-action report captured the revolutionary nature of what had occurred. The Hellcat had performed beyond all expectations, providing American pilots with advantages they had never possessed in Pacific combat. The aircraft's combination of speed, firepower, and protection allowed tactical approaches that would have been suicidal in earlier fighters. Most importantly, the Hellcat's forgiving handling characteristics enabled average American pilots to engage and defeat veteran Japanese aviators who had previously seemed untouchable. News of the Hellcat's combat debut spread rapidly through the Pacific Fleet, generating excitement that bordered on euphoria among pilots who had spent months flying obsolete fighters against superior enemies. The psychological impact proved as important as the tactical victory. For the first time since Pearl Harbor, American naval aviators possessed equipment that gave them decisive advantages over their Japanese counterparts. The long defensive phase of the Pacific War was finally ending. Admiral Halsey's reaction to the combat reports reflected the strategic significance of what had occurred. The Hellcat had proven itself capable of achieving air superiority against Japan's best pilots flying their most advanced aircraft. The Sate American offensive technological breakthrough would accelerate operations while forcing Japanese commanders to reconsider fundamental assumptions about their tactical advantages. The balance of power in Pacific aviation had shifted decisively in favor of the United States. The Japanese High Command's analysis of the engagement revealed the full scope of American technological achievement. Intelligence officers studying gun camera footage and pilot reports concluded that the Americans had produced not just a superior fighter, but an entirely new class of carrier aircraft. The Hellcat's performance characteristics exceeded Japanese estimates of what was possible within the constraints of carrier aviation. More disturbing still was the recognition that American industrial capacity could produce such aircraft in quantities that would overwhelm Japanese defenses. Within weeks of the September engagement, Hellcat production at facility accelerated Grumman's Beth-Pajeted to meet overwhelming Navy demand. Every carrier air group requested immediate conversion to the new fighter. Pilot training programs expanded to accommodate the influx of aviators eager to fly aircraft that finally gave them decisive advantages over their enemies. The transformation of American carrier aviation was beginning in earnest. The ripple effects extended far beyond individual air groups. Strategic planning for future Pacific operations could now assume American air superiority over target areas. The island hopping campaign that would carry American forces across the Central Pacific became feasible only because commanders knew that Hellcats could establish and maintain control of the skies above invasion beaches. The fighter that had begun as a response to Japanese air superiority had become the foundation for American offensive strategy. But the Hellcats' greatest triumph was yet to come. The September engagement had been fought against veteran Japanese pilots flying from established bases with adequate maintenance and supply support. The real test would come when American carrier task forces penetrated deep into Japanese controlled waters, where enemy air power could concentrate overwhelming numbers against isolated American formations. The Hellcat would need to prove itself not just in individual combat, but in the massive aerial battles that would determine the outcome of the Pacific War. The opportunity for that ultimate test arrived sooner than anyone anticipated. On November 20th, 1943, Operation Galvanic commenced with simultaneous American assaults on Tarawa and Makan atolls in the Gilbert Islands. Those heavily fortified Japanese strongholds lay deep within enemy-controlled waters, over 2,000 miles from the nearest American base. The invasion force would depend entirely on carrier-based air power for protection, making the operation the most ambitious test of American naval aviation since the war began. Task Force 58, under the command of Rear Admiral Charles Pownall, represented the largest concentration of American carrier power ever assembled. 6 fleet carriers and 5 light carriers embarked over 700 aircraft, with nearly 400 of them being the new F6F Hellcats. The sheer scale of the operation demonstrated American industrial capacity at its peak. Just 18 months after Pearl Harbor, the United States Navy possessed more carrier-based fighters than Japan had deployed in their entire opening offensive. The Japanese response was swift and massive. Admiral Manechi Koga, commanding the combined fleet from his headquarters at Truk, understood that the Gilbert Islands assault represented more than a tactical operation. American success would breach the outer ring of Japanese defenses and open the path toward the Central Pacific strongholds that protected the home islands themselves. Every available aircraft in the Marshall and Caroline Islands was ordered to converge on the invasion fleet. Lieutenant Commander David McCampbell, commanding VF-15 aboard USS Essex, studied intelligence reports that painted a sobering picture of Japanese air strength in the region. Over 300 aircraft were positioned within striking range of the Gilberts, including veteran squadrons equipped with the latest A6M50 variants and twin-engine G4M Betty bombers carrying powerful torpedoes. The numbers suggested that American forces would face concentrated air attacks exceeding anything encountered during the Guadalcanal campaign. The first major test came at dawn on November 21st as Japanese reconnaissance aircraft probed the American task force perimeter. Lieutenant Junior Grade Cecil Harris, flying combat air patrol at 25,000 feet, intercepted a lone Nakajima C-6N Mert attempting to photograph the invasion fleet. The engagement lasted less than 30 seconds. Harris's Hellcat easily overtook the speedy reconnaissance aircraft and a brief burst from his 650 caliber guns sent the Japanese plane spiraling into the ocean in flames. What followed was a systematic demonstration of Hellcat's superiority that left Japanese commanders struggling to comprehend the transformation in American capabilities. Wave after wave of Japanese aircraft approached the task force, only to be intercepted by Hellcat formations that seemed to appear from nowhere. The American fighters' superior radar directed interception capabilities, combined with their overwhelming performance advantages, created a killing field around the invasion fleet that Japanese aircraft could not penetrate. The morning of November 23rd brought the largest Japanese air attack of the Gilbert's operation. 68 aircraft, including 42 Zeros and 26 Betty bombers, approached Task Force 58 in a coordinated strike designed to overwhelm American defenses through sheer numbers. The formation represented nearly a quarter of available Japanese air strength in the Central Pacific, a desperate gamble to stop the American advance before it could gain momentum. Commander McCampbell led 32 Hellcats in the interception, climbing rapidly toward the incoming raid while maintaining perfect formation discipline. The Japanese strike leader, Lieutenant Commander Takeshi Maeda, watched with growing alarm as the American fighters approached. These weren't the scattered defensive formations that Japanese pilots had grown accustomed to engaging. The Hellcats climbed in tight sections, their pilots displaying tactical sophistication that spoke of extensive training and absolute confidence in their equipment. The engagement began at 0934 hours when McCampbell's leading division rolled into their attack. The Hellcats dove from 28,000 feet, their massive engines howling as they accelerated past 450 miles per hour. The structural integrity that had seemed like over-engineering during peacetime testing proved crucial as the fighters pulled out of their dives without structural failure or loss of control effectiveness. Japanese pilots, accustomed to American fighters that avoided high-speed combat, found themselves facing an entirely new tactical approach. Lieutenant Junior Grade Alexander Vracu, now an experienced Hellcat pilot with 5 confirmed kills, targeted the Lyd Betty bomber in a diving attack that demonstrated the revolutionary firepower of American heavy fighters. His 6 machine guns opened fire at 400 yards, and the concentrated stream of 50 caliber projectiles tore through the bomber's unprotected fuel tanks and crew compartments. The G4M, known to American pilots as the Flying Zippo for its tendency to catch fire, exploded in a massive fireball that could be seen for miles across the Pacific. The psychological impact on Japanese pilots proved as devastating as the physical destruction of their aircraft. Veteran aviators who had survived 2 years of Pacific combat found themselves facing firepower and performance that exceeded their worst fears. The Hellcats seemed immune to the traditional Japanese advantages of maneuverability and pilot experience. American pilots, many with fewer than 100 hours of combat time, were systematically destroying formations led by aces with hundreds of victories. Petty Officer First Class Tetsuzo Iwamoto, one of Japan's leading fighter aces with over 200 confirmed kills, found his Zero helpless against Lieutenant Commander Edward O'Hare's Hellcat during a turning engagement that should have favored Japanese aircraft. The American fighter maintained its energy advantage throughout the combat, using superior power and structural strength to dictate engagement terms while delivering accurate fire that forced Iwamoto into increasingly desperate, evasive maneuvers. The ammunition expenditure during the Gilbert's operation revealed the scale of American industrial support for Pacific operations. Hellcat squadrons fired over 400,000 rounds of 50 caliber ammunition during 3 days of continuous combat, quantities that would have exhausted Japanese supplies for months. American logistics ships replenished fighter ammunition daily, ensuring that pilots never faced the ammunition shortages that plagued Japanese forces throughout the war. The technological superiority extended beyond basic performance characteristics to sophisticated systems that gave American pilots decisive advantages in combat. The Hellcat's advanced gun sight, developed specifically for the aircraft, provided accuracy that exceeded anything available to Japanese pilots. The sight automatically calculated lead angles and range compensation, allowing even novice pilots to achieve hit probabilities that veteran Japanese aviators could match only through years of experience. By November 24th, Japanese air resistance in the Gilberts had effectively collapsed. Of the 300 aircraft initially available to contest the invasion, fewer than 50 remained operational. The survivors were scattered across distant bases, their pilots demoralized by encounters with American fighters that seemed invulnerable to traditional Japanese tactics. The kill ratio achieved by Hellcat squadrons exceeded 10 to 1, a level of air superiority that made continued Japanese resistance pointless. Commander Maeda, one of the few Japanese pilots to survive multiple encounters with Hellcat formations, transmitted a final report to his headquarters that captured the hopelessness of Japan's situation. The Americans had produced not just superior aircraft, but an entirely new approach to naval aviation that combined technological excellence with tactical sophistication and overwhelming numbers. Japanese pilots, no matter how skilled or experienced, could not overcome such systematic advantages. The strategic implications of the Gilbert's air battles extended far beyond the immediate tactical victory. Japanese commanders realized that their entire defensive strategy, based on the assumption of continued air superiority, had become obsolete. American carrier task forces could now penetrate deep into Japanese-controlled waters while maintaining complete air superiority over their operations. The outer ring of Pacific defenses that had seemed impregnable just months earlier was now vulnerable to systematic American assault. Admiral Koga's analysis of the Gilberts' defeat painted a stark picture of Japan's deteriorating position. The Americans possessed not only superior aircraft, but the industrial capacity to replace losses while continuously improving their equipment. Japanese aircraft production, hampered by material shortages and outdated manufacturing techniques, could not keep pace with American output. More critically, Japan's pilot training system, optimized for producing small numbers of highly skilled aviators, could not replace the veterans being lost in combat against overwhelming American numbers. The Hellcat's performance during Operation Galvanic established patterns that would define the remainder of the Pacific War. American carrier task forces could operate with impunity in waters previously considered Japanese strongholds. The island hopping strategy that would carry American forces across the Central Pacific became feasible only because commanders could assume air superiority over their objectives. The fighter designed to counter Japanese advantages had become the foundation of American offensive strategy. But the full measure of Hellcat's superiority would be revealed during the next major carrier engagement. The Great Marianas Turkey Shoot, still 6 months in the future, would pit the entire remaining strength of Japanese carrier aviation against American task forces spearheaded by over 400 Hellcats. That engagement would demonstrate conclusively that Japanese air power, once the terror of the Pacific, had become merely target practice for American pilots flying the most successful carrier fighter in aviation history. The transformation was already visible in the confidence of American pilots and the desperation of Japanese commanders. Where once the sight of Japanese aircraft had struck fear into Allied forces, now it was American formations that inspired dread among enemy pilots. The Hellcat had not merely achieved air superiority, it had inverted the entire psychology of Pacific air combat. Japanese pilots, who had once hunted American fighters with impunity, now found themselves the hunted facing aircraft and pilots that seemed invincible in their technological and numerical supremacy. The transformation in American pilot morale was perhaps as significant as the technological revolution they were flying. Lieutenant Junior Grade Robert Duncan, writing to his family after his first combat mission in a Hellcat, captured the psychological shift perfectly. For the first time since I arrived in the Pacific, I'm not afraid of the Zeros. The Hellcat makes me feel like I'm flying a battleship with wings. Their bullets bounce off, and when I pull the trigger, they just disintegrate. This confidence wasn't misplaced bravado, but the result of systematic engineering designed to keep American pilots alive while maximizing their combat effectiveness. The Hellcat's armor protection had been calculated down to the last ounce, providing coverage against the specific ammunition types used by Japanese aircraft. The pilot sat behind a steel plate capable of stopping 20 mm cannon shells, while bullet-resistant glass protected him from frontal attacks. Even the engine, massive as it was, incorporated armor plating that could absorb direct hits from Japanese weapons while continuing to operate. The self-sealing fuel tanks represented another crucial advantage that Japanese pilots discovered to their horror. Where a few incendiary rounds could turn a Zero into a torch, the same ammunition merely sealed punctures in Hellcat fuel systems, allowing damaged aircraft to return home. Grumman engineers had studied every aspect of combat damage, creating redundant systems and protective measures that gave American pilots multiple chances to survive encounters that would have been fatal in earlier fighters. Japanese intelligence officers, analyzing wreckage from shot down Hellcats, were astounded by the sophistication of American engineering. Every component seemed overbuilt by Japanese standards, incorporating safety margins that appeared wasteful until viewed in the context of sustained combat operations. The Americans weren't just building fighters, they were building weapons systems designed to operate continuously under conditions that would destroy more lightly constructed aircraft. The manufacturing quality itself became a weapon of war. While Japanese aircraft production suffered from material shortages and declining craftsmanship standards, American factories maintained precision that exceeded peacetime requirements. Each Hellcat rolled off the production line with tolerances measured in thousandths of an inch, ensuring that spare parts from different manufacturers would fit perfectly in combat conditions. This interchangeability allowed rapid field maintenance that kept American squadrons at full strength, while Japanese units struggled with chronic parts shortages. The Pratt and Whitney R2800 engine that powered the Hellcat represented American industrial might at its most sophisticated. The 18-cylinder radial required over 15,000 individual components, each manufactured to specifications that demanded the most advanced metallurgy and precision machining techniques available. The engine's reliability in combat conditions far exceeded Japanese power plants, which had been designed for shorter operational lifespans and less demanding service conditions. Combat maintenance procedures reflected this engineering philosophy. Where Japanese aircraft required extensive servicing after every mission, Hellcats could operate for hundreds of hours between major overhauls. American carrier mechanics could perform engine changes in hours rather than days, keeping fighters available for the constant operations that characterized Pacific warfare. This maintenance advantage multiplied the effective strength of American squadrons as more aircraft remained mission ready at any given time. The ammunition logistics alone demonstrated American industrial supremacy. Each Hellcat sortie required 2,400 rounds of .50 caliber ammunition, with combat missions potentially expending the entire load in minutes of intensive fighting. American ammunition ships carried millions of rounds, ensuring that fighters could maintain maximum combat loads throughout extended operations. The cartridges themselves incorporated advanced propellants and projectiles that delivered greater muzzle velocity and hitting power than anything in Japanese arsenals. By January 1944, Hellcat production had reached levels that defied Japanese comprehension. The Bethpage facility was completing 5 aircraft daily, while a second production line in Tulsa, Oklahoma, added another 3 per day. This meant that American factories were producing more Hellcats each week than Japan could manufacture fighters of all types in a month. The mathematics of attrition warfare had shifted decisively in favor of the United States. The pilot training pipeline supporting Hellcat operations represented an equally impressive achievement. Naval Air Training Command was graduating 500 new fighter pilots monthly, each with over 200 hours of flight training before reaching combat squadrons. Advanced training included tactics specifically developed for Hellcat operations, teaching pilots to exploit their aircraft's advantages while avoiding situations where Japanese experience might prove decisive. This systematic approach to pilot development ensured that American squadrons maintained their effectiveness even as they absorbed losses and rotated personnel. Lieutenant Commander John Thatch, the same pilot whose desperate tactics had kept his Wildcats alive during the dark days of 1942, now found himself developing offensive doctrines for Hellcat squadrons. The transformation in American capabilities allowed tactical approaches that would have been suicide just months earlier. Thatch's new formations emphasized speed and firepower over defensive maneuvering, teaching pilots to use their overwhelming advantages to destroy Japanese aircraft before they could bring their superior agility to bear. The psychological impact on Japanese pilots intensified with each encounter. Flight Petty Officer Kaneyoshi Muto, a veteran of Pearl Harbor and the Coral Sea, wrote in his diary after surviving an engagement with Hellcats over Kwajalein, "The Americans fly like they know they cannot be defeated. They attack with absolute confidence, using tactics that would be reckless if their aircraft were not so superior. We who once hunted them now flee at their approach." This demoralization spread throughout Japanese naval aviation as news of Hellcat encounters circulated among squadrons. Pilots who had grown accustomed to aerial superiority found themselves facing aircraft that seemed invulnerable to their weapons while delivering firepower that could destroy any Japanese fighter with a brief burst. The psychological advantage that had sustained Japanese forces through the early war years was rapidly shifting to their enemies. The technological gap extended beyond basic performance to sophisticated systems that gave Hellcat pilots decisive advantages in combat. The aircraft's electrical system powered advanced radios that allowed coordinated attacks impossible with Japanese equipment. Formation leaders could direct complex tactical maneuvers while maintaining communication with supporting units, creating a level of battlefield coordination that Japanese pilots had never experienced from their opponents. The gun sight technology represented another crucial American advantage. The Hellcat's Mark 8 reflector sight automatically calculated lead angles and range compensation, allowing pilots to achieve hit probabilities that Japanese aviators could match only through years of combat experience. Combined with the concentrated firepower of 6.50 caliber machine guns, this aiming system ensured that even brief firing opportunities could prove lethal to Japanese aircraft. Navigation equipment gave American pilots capabilities that seemed almost supernatural to their enemies. The Hellcat's radio compass and advanced instruments allowed precise navigation in conditions where Japanese pilots became lost or disoriented. American formations could attack from unexpected directions and withdraw along carefully planned routes that maximized their advantages while minimizing exposure to enemy counterattacks. The maintenance revolution supporting Hellcat operations impressed even experienced Navy personnel. Chief Petty Officer William Morrison, a veteran mechanic with 20 years of naval service, marveled at the aircraft's serviceability. "We can turn around a Hellcat in 30 minutes. New ammunition, fuel, oil check, and she's ready for another mission." The Zero pilots we captured tell us their aircraft needed hours of maintenance after every flight. No wonder they can't keep up with our operations tempo. This maintenance advantage multiplied American combat effectiveness by ensuring maximum aircraft availability during critical operations. While Japanese squadrons struggled to maintain half their aircraft in mission-ready condition, American units routinely achieved availability rates exceeding 90%. The cumulative effect gave American commanders numerical advantages that went far beyond simple production numbers. The supply chain supporting Pacific Hellcat operations represented logistical achievement on an unprecedented scale. Ammunition, fuel, spare parts, and replacement aircraft flowed across thousands of miles of ocean with clockwork precision. American carriers could maintain continuous operations for weeks, while Japanese forces struggled with chronic shortages of everything from aviation gasoline to machine gun ammunition. Intelligence gathered from captured Japanese pilots revealed the extent of their logistical difficulties. Many had been flying aircraft with unfilled fuel tanks due to gasoline shortages. Others reported ammunition rationing that limited their combat effectiveness. Some had been ordered to avoid combat unless absolutely necessary to preserve their dwindling aircraft for more critical missions. These shortages contrasted sharply with American abundance. Hellcat pilots could afford to expend ammunition freely, knowing that resupply was readily available. They could push their aircraft to maximum performance limits without worrying about premature engine failures or maintenance delays. This freedom from resource constraints allowed aggressive tactics that maximized the Hellcat's inherent advantages. The training revolution extended beyond individual pilot skills to squadron level tactics that leveraged American technological superiority. Combat formations were redesigned around the Hellcat's capabilities, emphasizing coordinated attacks that could overwhelm Japanese defenses through sheer firepower and speed. These new tactics required extensive practice and coordination, but American training resources made such preparation possible on a scale that Japanese forces could never match. By February 1944, the transformation of Pacific air warfare was complete. Japanese commanders recognized that their traditional advantages had been neutralized by American technological and industrial superiority. The Zero, once the terror of Allied pilots, had become little more than a target for Hellcat formations that seemed to appear everywhere Japanese aircraft ventured. The psychological reversal was as complete as the technological one. The strategic implications extended far beyond individual air battles. American planners could now assume air superiority over any target within carrier aircraft range. This assumption made possible the ambitious operations that would characterize the final phase of the Pacific War. The island hopping campaign that would carry American forces to Japan's doorstep became feasible only because the Hellcat had broken Japanese air power so completely. But the ultimate test of American air superiority still lay ahead. The Great Marianas Turkey Shoot would pit the entire remaining strength of Japanese carrier aviation against the largest American task force ever assembled. That engagement would demonstrate conclusively that the Hellcat had not merely achieved tactical superiority, but had fundamentally altered the strategic balance in the Pacific. Japanese naval aviation, once the most formidable air force in the world, was about to face complete and final destruction at the hands of American pilots flying the most successful carrier fighter in history. The stage was set for the final act of the Pacific Air War, where the technological revolution embodied in the F6F Hellcat would deliver the decisive blow that would clear the skies for America's advance to victory. The morning of June 19th, 1944 dawned clear and calm over the Philippine Sea, but beneath the deceptively peaceful surface, the largest naval battle in history was about to unfold. Vice Admiral Chisaburo Ozawa, commanding the mobile fleet from his flagship Taiho, studied intelligence reports that painted an ominous picture. Task Force 58, under Admiral Raymond Spruance, had assembled 15 fleet carriers and nearly 900 aircraft for Operation Forager, the assault on Saipan and the Marianas Islands. Against this armada, Ozawa could muster only 9 carriers and 473 aircraft, including 222 A6M Zero fighters that represented the last reserve of trained Japanese naval aviators. What Ozawa didn't realize as he planned his desperate gamble was that his pilots were about to face not just superior numbers, but a technological and tactical revolution that would render Japanese air power obsolete forever. The 450 F6F Hellcats aboard American carriers represented 18 months of combat evolution, their pilots trained in tactics specifically designed to exploit every weakness in Japanese aircraft and doctrine. The engagement about to unfold would be remembered as the Great Marianas Turkey Shoot, the most one-sided aerial victory in military history. Lieutenant Commander David McCampbell, leading Air Group 15 from USS Essex, understood the magnitude of what was approaching. His intelligence briefings had revealed the composition of Ozawa's force, including veteran squadrons from carriers that had participated in every major Pacific engagement since Pearl Harbor. These weren't the inexperienced replacement pilots that American forces had been encountering with increasing frequency. These were the last of Japan's elite naval aviators, flying in a final desperate attempt to halt American advances toward the home islands. The Japanese plan reflected both tactical sophistication and strategic desperation. Ozawa intended to launch his aircraft at maximum range, striking the American task force while remaining beyond the reach of counterattack. His planes would then recover at airfields on Guam and Saipan, refuel and rearm, and launch additional strikes during their return flight to the mobile fleet. The concept, known as the shuttle bombing technique, promised to multiply Japanese striking power while keeping precious carriers out of danger. But American intelligence had penetrated Japanese communications, providing spruance with detailed knowledge of enemy intentions. More critically, the airfields that were supposed to support the shuttle bombing operation had been systematically destroyed by preliminary strikes. Held swept-cat formations, Ha over Guam and Saipan 4, destroying Day's aircraft on the ground and cratering runways until the islands could no longer support large-scale aviation operations. At 0830 hours, radar operators aboard USS Lexington detected the first wave of Japanese aircraft approaching from the west. Raid I consisted of 69 aircraft, including 45 Zero fighters, escorting 24 Judy dive bombers, flying at 18,000 feet and closing at 200 knots. The formation represented Ozawa's most experienced pilots, led by Lieutenant Commander Zenji Abe, whose had been flying squadron together since the China campaign of 1937. Commander Charles Brewer, controlling fighter direction aboard Lexington, orchestrated the American response with precision that reflected months of tactical development. 8 Hellcat divisions, totaling 32 fighters, were vectored to intercept raiders while additional squadrons climbed to altitude as backup. The Americans possessed advantages that Japanese pilots had never faced in combination: superior aircraft, better training, coordinated tactics, and overwhelming numbers. Lieutenant Alexander Vratsiu, now the leading ace of V, led his F-16 division toward the intercept at 24,000 feet. Through his canopy, he could see the Japanese formation maintaining tight discipline despite approaching certain destruction. These pilots knew they were flying into a trap, but their dedication to duty compelled them forward into combat they could not win. Vratsiu respected their courage, even as he prepared to destroy them with clinical efficiency. The engagement began at 09:18 hours when Varasyu's division rolled into their attack from directly above the Japanese formation. The Hellcats dove at 450 miles per hour, their structural strength allowing maneuvers that would have torn apart lighter aircraft. Japanese pilots, expecting traditional diving attacks that could be countered through superior maneuverability, found themselves facing tactics specifically designed to negate their advantages. The first Zeros fell to Vrasyu's guns in less than 5 seconds of combat. The Japanese pilot, attempting a climbing turn to escape the diving American fighter, watched in horror as the Hellcat followed him through the maneuver without losing speed or position. Vrakyu's 6.50 caliber machine guns spoke once, and the Zero disintegrated under concentrated fire that no Japanese aircraft could survive. The pilot never had time to understand how American fighters had become so devastatingly effective. Lieutenant Junior Grade Brian Johnson, flying wing position in Vrasyu's division, destroyed two Zeros in quick succession using tactics that would have been impossible in earlier American fighters. His Hellcat's superior power allowed him to maintain energy advantages throughout turning combat, while his advanced gun sight enabled accurate fire even during high G maneuvers. The Japanese pilots, veterans with thousands of hours of experience, found their expertise useless against aircraft that negated every advantage they had spent years developing. The massacre that followed redefined the mathematics of aerial warfare. In 18 minutes of combat, American fighters destroyed 42 Japanese aircraft while losing only one Hellcat. The kill ratio of 42-1 exceeded anything achieved in aviation history, demonstrating the complete technological obsolescence of Japanese air power. Pilots who had terrorized Allied forces for 2.5 years were reduced to helpless targets for American teenagers flying their first combat missions. Raid 2, consisting of 128 aircraft, including 53 Zero fighters, met the same fate 30 minutes later. Commander William Dean, leading VF-2 from USS Hornet, intercepted the formation at 19,000 feet with devastating results. The Japanese had attempted to learn from the destruction of Raid 1, approaching at lower altitude with better fighter escort ratios. Nothing they tried made any difference against Hellcat formations that seemed to anticipate every tactical adjustment. Lieutenant Junior Grade William Foltz achieved 5 kills during the Raid 2 engagement, becoming an ace in a single mission while flying his 4th combat sortie. His victims included a veteran Japanese flight leader with over 200 hours of combat experience, demonstrating how completely American technological advantages had overturned traditional measures of pilot effectiveness. Experience meant nothing when facing aircraft that could outperform, outgun, and outlast anything in Japanese arsenals. The psychological impact on surviving Japanese pilots proved as devastating as the physical destruction of their aircraft. Those few who managed to escape described encounters with American fighters that seemed invulnerable to damage while delivering firepower that instantly destroyed any Japanese aircraft it touched. Radio transmissions, intercepted by American intelligence, revealed panic spreading through Japanese formations as pilots realized they were facing opponents they could not defeat. Raid 3 and 4 suffered similar fates throughout the afternoon, with American fighters destroying Japanese aircraft at ratios that defied pre-war assumptions about air combat. The Hellcat pilots, many with fewer than 50 hours of combat time, were systematically annihilating formations led by aces with hundreds of victories. The technological revolution had reached a point where pilot skill mattered far less than aircraft capabilities and tactical doctrine. By 1600 hours, Japanese losses had reached catastrophic proportions. Of 373 aircraft launched that morning, only 35 returned to their carriers. The mobile fleet's air strength had been effectively destroyed in a single day, with veteran pilots representing irreplaceable training investments lost forever. Ozawa's gamble had not merely failed, it had eliminated Japanese naval aviation as an effective fighting force. The American losses told an equally dramatic story from the opposite perspective. Task Force 58 lost 29 aircraft during the day's fighting, with most losses attributed to operational accidents rather than enemy action. The exchange ratio of nearly 13 to 1 in aircraft, combined with pilot loss ratios exceeding 20 to 1, represented military victory on a scale rarely achieved in warfare. Japanese naval aviation had been not merely defeated, but annihilated. Lieutenant Commander McCampbell's analysis of the day's combat captured the revolution that had occurred in Pacific aviation. The Hellcat had evolved beyond its original design parameters into a weapon system that gave average American pilots decisive advantages over Japan's most experienced aviators. The combination of superior performance, overwhelming firepower, and advanced tactics had created a level of air superiority that made continued Japanese resistance futile. The strategic implications extended far beyond the immediate tactical victory. With carrier-based air power eliminated, Japanese forces could no longer contest American operations anywhere within range of Task Force 58. The Marianas would fall, providing bases for B-29 bombers that could reach Japan itself. The outer ring of Pacific defenses had collapsed completely, leaving the home islands vulnerable to direct assault. Admiral Ozawa's final radio message to Combined Fleet Headquarters revealed the magnitude of Japanese defeat. His carrier air groups had been practically wiped out, with surviving pilots moralized beyond recovery. The mobile fleet retained its ships, but had lost the air wings that gave them offensive capability. Japanese naval aviation, once the most formidable air force in the world, had been reduced to ineffectiveness in a single afternoon. The technological superiority that had made this victory possible continued expanding as American industry reached peak wartime production. New Hellcat variants incorporated lessons learned from 18 months of Pacific combat, while pilot training programs graduated increasingly skilled aviators. The gap between American and Japanese capabilities was widening rather than narrowing, ensuring that future engagements would prove even more one-sided. But perhaps the most significant aspect of the turkey shoot was what it revealed about American industrial philosophy. The Hellcat hadn't achieved victory through elegant engineering or revolutionary design concepts. Instead, it represented brute force application of superior resources, manufacturing precision, and systematic tactical development. American engineers had studied Japanese advantages methodically, then built aircraft and training systems that negated those advantages through overwhelming superiority in every measurable category. The pilots flying those Hellcats embodied the same systematic approach to warfare. They weren't necessarily more skilled individually than their Japanese opponents, but they flew better aircraft, used superior tactics, and operated within logistic systems that ensured constant readiness for combat. The combination of technological and organizational advantages had created military effectiveness that Japanese forces, regardless of their courage and dedication, simply could not match. As the sun set over the Philippine Sea on June 19th, 1944, the age of Japanese air superiority had ended forever. The Zero fighters that had once struck fear into Allied hearts were now merely historical curiosities, outclassed by American aircraft that seemed to improve with each new variant. The Hellcat had not just broken Japanese air dominance, it had inverted the entire psychology of Pacific aviation warfare. The F6F Hellcat didn't just defeat the Zero, it obliterated the entire foundation of Japanese naval aviation. From that desperate morning when John Thatch's Wildcats faced impossible odds, to the turkey shoot that erased Japan's last veteran pilots from Pacific skies, the Hellcat represented more than technological advancement. It embodied American industrial might transformed into aerial supremacy, proving that systematic engineering and overwhelming production could indeed rewrite the rules of warfare and clear the path to Tokyo Bay.